Imagine a place where gravity is so powerful that nothing, not even light, can escape. A place where time slows down, space itself bends, and the laws of physics as we know them begin to unravel. These cosmic enigmas are called black holes. For decades, black holes have captured the imagination of scientists and dreamers alike. They're not just massive objects lurking in the darkness. They're gateways to understanding the deepest mysteries of the universe. From Einstein's equations to Hollywood blockbusters, black holes continue to blur the line between science and science fiction. But what exactly are they? And why do they hold such a powerful grip on our curiosity? The birth of a black hole. The journey of a black hole begins with the life of a massive star, a giant many times heavier than our own sun. These colossal stars shine with incredible brilliance, fusing hydrogen into helium in their fiery cores. Over millions of years, they forge heavier and heavier elements, building the raw ingredients for the universe itself. But this blazing life cannot last forever. As the star exhausts its nuclear fuel, the delicate balance between outward pressure and inward gravity begins to break. Gravity, the invisible sculptor of the cosmos, slowly wins. The star's core collapses under its own immense weight, and in that moment, one of nature's most breathtaking spectacles unfolds: the supernova. In a blinding explosion, the outer layers of the star are hurled into space, scattering stardust across the galaxy. For a brief time, that single star can outshine billions of others, creating the heavy elements that one day may form planets, oceans, and even life itself. But what remains after the explosion is far more mysterious. Deep at the center, the core continues to collapse, shrinking smaller and smaller until it reaches a point of no return. Matter is crushed into an almost unimaginable density, a place where the known laws of physics begin to fail. This is the singularity, an infinitely small point with infinite gravity. Around the singularity forms the event horizon, an invisible boundary that marks the edge of the black hole. Beyond this horizon, nothing can escape, not even light itself. What was once a star has now transformed into one of the most enigmatic objects in the universe: a black hole, a cosmic abyss from which no traveler returns. Anatomy of a black hole. To understand a black hole, we must look closer at its anatomy, though in truth, much of it remains hidden behind a veil of mystery. Still, science gives us glimpses into its strange structure. Singularity. At the very heart lies the singularity, a place where matter is crushed into an infinitely small point. Here, density and gravity reach extremes that our current physics cannot fully explain. Time and space themselves appear to break down. It is the ultimate unknown, a cosmic riddle at the center of every black hole. Event horizon. Surrounding this singularity is the event horizon, an invisible boundary that marks the point of no return. Once anything crosses it, whether a star, a planet, or even a beam of light, escape becomes impossible. To an outside observer, time seems to freeze at this edge, as though the universe itself hesitates at the threshold of eternity. Accretion disk. Yet not everything is swallowed in silence. Around the event horizon swirls the accretion disk, a glowing whirlpool of gas, dust, and broken fragments of stars. As matter spirals inward, friction and gravity heat it to millions of degrees, causing it to blaze with X-rays and visible light. In the darkness of the cosmos, the accretion disk shines like a fiery halo, betraying the presence of the black hole within. Jets in energy emissions. And then, paradoxically, black holes can also unleash energy on a scale beyond imagination. Powerful magnetic fields can twist and hurl matter away from the poles of the black hole, creating colossal jets of plasma that shoot across galaxies at nearly the speed of light. These jets can stretch for thousands of light years, sculpting the very structure of galaxies themselves. So within this darkness lies both destruction and creation, a singularity that consumes all, surrounded by forces that radiate more energy than entire stars. Types of black holes. Not all black holes are created equal. In fact, they come in different sizes, each with its own origins and mysteries. The most common kind are stellar mass black holes, formed from the death of massive stars. They typically weigh between a few times the mass of our sun and up to a few dozen. Scattered across the galaxy, these invisible remnants are often found quietly pulling in matter from companion stars or wandering through the darkness unseen. At the opposite extreme are the true giants, supermassive black holes. These monsters contain millions, sometimes billions, of solar masses packed into a single gravitational abyss. At the heart of almost every galaxy, including our own Milky Way, lurks one of these titans. How they formed remains one of the greatest puzzles of modern astrophysics. Did they grow slowly over billions of years? Or were they born already colossal in the early universe? The answer may reshape our understanding of cosmic evolution. Between these extremes lies a mysterious middle ground, intermediate black holes. Ranging from hundreds to thousands of solar masses, they are elusive and difficult to detect. Astronomers have only recently begun to find evidence for them, perhaps hiding in dense star clusters or in the quiet outskirts of galaxies. If confirmed, they may hold the key to explaining how supermassive black holes came to be. And then, there is the strangest possibility of all, primordial black holes. These hypothetical objects may have formed not from stars, but from the very fabric of the early universe, moments after the Big Bang. If they exist, they could range from microscopic specks to planetary-sized objects. Some even speculate they might make up part of the mysterious dark matter that fills the cosmos. For now, they remain theory, but the search continues. From the stellar to the supermassive, from the proven to the speculative, black holes exist across a cosmic spectrum, silent witnesses to the birth, growth, and evolution of the universe itself. How we detect black holes. Black holes are invisible by nature. They emit no light, no signal, no direct clue to their presence. And yet humanity has found ways to uncover these cosmic phantoms. We cannot see them directly, but we can trace their fingerprints across the universe. The first hint often comes from the way black holes bend the dance of nearby stars. An unseen force pulls at them, whipping them into strange orbits at incredible speeds. Astronomers peering through telescopes watch these stellar motions and realize something massive, something invisible lurks in the darkness. It is gravity itself pointing to the black hole. Sometimes a black hole reveals its hunger. As gas and dust spiral inward, they form a blazing accretion disk. This disk glows with extreme radiation, from X-rays to visible light, as matter is torn apart and heated to millions of degrees. Space telescopes catch these emissions, giving us a fiery outline of the black hole's feeding frenzy. Another path to discovery comes from the ripples of space-time itself. When two black holes collide, their violent merger shakes the fabric of the universe, sending out gravitational waves that travel across billions of light years. In 2015, detectors on Earth captured these waves for the first time, a cosmic vibration that confirmed Einstein's boldest predictions and opened a new era of astronomy. And then, history was made in 2019. For the first time, humanity captured an image of a black hole's shadow. Using a global network of radio telescopes, scientists formed the Event Horizon Telescope, effectively turning Earth into one giant observatory. The result was breathtaking, a glowing orange ring encircling a dark void, the silhouette of the event horizon itself. For the first time, the unseeable became visible. Through the dance of stars, the heat of falling matter, the ripples in space-time, and the power of global collaboration, we are learning to shine light on the darkest objects in the universe. Black holes are not just objects, they are extreme laboratories where the universe bends its own rules. To understand them, we must enter the strange world of modern physics. Einstein's theory of general relativity revealed that gravity is not simply a force, but the warping of space and time itself. Massive objects bend the cosmic fabric around them, and nothing bends it more violently than a black hole. Near its core, space-time folds so sharply that all paths lead inward, even the paths of light. In such warped space-time, time itself behaves strangely. To a distant observer, a falling object appears to slow down as it nears the event horizon, almost freezing at the edge. But for the traveler plunging in, time flows normally as they are pulled toward their fate. This phenomenon, called time dilation, makes black holes not only destroyers of matter, but also distorting mirrors of time itself. And yet, black holes may not last forever. In the 1970s, physicist Stephen Hawking made a startling prediction. Black holes can slowly lose mass through a process now called Hawking radiation. Tiny quantum particles constantly flicker in and out of existence in empty space. Near a black hole's event horizon, these particles can be split apart. One escapes into space, while the other falls inward. Over unimaginable timescales, this trickle of energy could cause a black hole to shrink and eventually vanish, evaporating into nothing but a whisper of radiation. If true, Hawking radiation means that even these cosmic giants are not eternal. They too are bound to the fate of time. In the physics of black holes, we find paradoxes and possibilities that push science to its very limits, where gravity, quantum mechanics, and time itself collide in the ultimate cosmic mystery. Black holes in the universe. Black holes are not just strange curiosities hidden in the corners of space. They are architects of the cosmos itself. Their influence stretches far beyond their dark horizons, shaping galaxies, driving evolution, and offering clues to the deepest laws of reality. At the heart of nearly every large galaxy lies a supermassive black hole, including our own Milky Way. Far from being passive monsters, these giants may have played a central role in the birth and growth of galaxies. Their gravitational pull helps anchor billions of stars, while their powerful jets and radiation can regulate star formation across entire regions of space. Without them, galaxies as we know them may never have formed. By feeding, black holes also give back. When they consume gas and dust, the energy released can heat and stir entire galactic neighborhoods, preventing matter from collapsing too quickly into stars. This delicate balance influences the pace of cosmic evolution, deciding when and where new stars and potentially new worlds can emerge. In this way, black holes are not just destroyers, but cosmic gardeners, shaping the life cycles of galaxies. And for scientists, black holes are more than cosmic engines. They are natural laboratories for the laws of physics. In their depths, the two great pillars of science, general relativity and quantum mechanics, clash in ways we cannot yet reconcile. Studying black holes may lead us to a deeper, unified theory of the universe. They force us to ask the biggest questions. What is time? What is space? And can something truly emerge from nothing? Black holes, once feared as eternal prisons, are now seen as vital players in the story of existence. They do not just lurk in the dark. They help write the history of the universe itself. Mysteries and theories. For all we know about black holes, even greater mysteries remain. At their core lies a frontier where science falters and imagination dares to step in. The singularity, the heart of the black hole, is a place where the known laws of physics collapse. Matter is crushed to infinite density, and space and time twist beyond recognition. What truly lies within? Is it simply an endpoint, a cosmic wall where reality breaks? Or is it a doorway to something we cannot yet conceive? Some theories suggest that black holes could be bridges, wormholes that link distant parts of our universe, or even gateways to entirely new universes. Perhaps every black hole bursts a new cosmos on the other side, with its own stars, galaxies, and laws of physics. In this view, our universe itself could be the child of a black hole formed in another, grander reality. So what are black holes truly? Are they the ultimate endings, eternal prisons where matter and energy vanish forever? Or are they beginnings, cosmic passageways that connect realities and give birth to new worlds? The truth remains hidden, waiting for discoveries that may reshape everything we believe about existence. In the darkness of black holes, we glimpse both the limits of human knowledge and the boundless possibilities of the cosmos. They remind us that the universe is still filled with secrets, and that the greatest mysteries may lie not in the stars we see, but in the voids we cannot. Black holes in human imagination. Black holes are not only objects of science, they are symbols that have captured the human imagination for centuries. They embody mystery, fear, and wonder, echoing through culture, art, and philosophy. In literature and art, black holes often appear as metaphors for the unknown, voids that consume not just matter, but meaning itself. They symbolize death, endings, and oblivion, but also rebirth, transformation, and the mystery that lies beyond human understanding. Writers and poets have long used the imagery of the black hole as a mirror of our deepest fears and desires, a symbol of both destruction and transcendence. In film and science fiction, black holes are among the most powerful storytelling devices. They appear as cosmic traps, dangerous gateways, and portals to alternate realities. From the terrifying maw of a starship's doom to the breathtaking wormhole of Interstellar, black holes allow us to imagine journeys beyond the limits of space and time. They inspire wonder while reminding us of the fragility of human existence against the scale of the universe. Philosophically, black holes invite us to confront the ultimate questions. Are they symbols of annihilation, reminders that even the brightest stars must one day fade into darkness? Or are they symbols of transcendence, thresholds to higher states of being, where endings become beginnings? To some, they represent fear, the void from which nothing escapes. To others, they suggest rebirth, a cosmic cycle where destruction becomes creation. In the end, black holes live not only in the heart of galaxies, but in the heart of human imagination. They remind us that the universe is not fully knowable, and that within its mysteries lies the spark of art, story, and meaning itself. Why black holes matter? Why do black holes matter? Because they stand at the crossroads of science, philosophy, and human curiosity. They are not just distant objects in space, they are keys to the deepest questions of existence. At their core, black holes expose a paradox. Einstein's general relativity describes their immense gravity, while quantum mechanics governs the tiniest particles within them. But at the singularity, these two pillars of science collide, and neither fully explains what happens. To solve the mystery of black holes is to take a step toward a grand unification of physics, a theory that could unlock the true nature of reality itself. Black holes may also carry secrets about the universe's beginning and its ultimate end. If they can create wormholes or even seed new universes, they may hold the blueprint of cosmic creation. Their growth and influence shape galaxies, star systems, and perhaps even the timeline of the cosmos. To study them is to study our own origins and to glimpse the possible futures that await the universe. And finally, black holes matter because of what they represent to us. They force us to face the unknown, to accept that there are realms of nature beyond our current understanding. For some, they inspire fear, an abyss from which nothing returns. For others, they ignite awe, proof that the universe is far larger, stranger, and more beautiful than we can yet imagine. In them, we find a reflection of ourselves, fragile beings reaching into the dark, searching for light, for knowledge, for meaning. Black holes remind us that the greatest mysteries of the cosmos are not only about what lies out there, but about what lies within us. From their violent birth in collapsing stars to their role as architects of galaxies, black holes stand as some of the most powerful and mysterious objects in the universe. We've explored their anatomy, singularities, horizons, and blazing disks, their different types, their effects on space and time, and the ways we've learned to detect them. We've seen how they shape cosmic evolution, challenge the limits of physics, and inspire art, story, and philosophy. And yet, for all we know, the greatest questions remain unanswered. What truly lies within the singularity? Are black holes gateways to other universes, or are they simply the ultimate endings? Will solving their mysteries finally unite general relativity and quantum mechanics into a single theory of everything? Black holes are more than cosmic abysses. They are symbols of the human spirit, of our endless hunger to understand what lies beyond. They remind us that even in the darkest places, there is discovery, there is meaning, and there is wonder. Perhaps the universe hides its deepest truths, not in the stars we see, but in the shadows that challenge us to imagine the unimaginable. And so, the story of black holes is far from finished. It is a story we are still writing, with every telescope, every equation, every question whispered into the night sky.